So let's say we wanna a little change the definition, the definition of the problem. So let's say, actually, we have lots of, this kind of playing in the interviews. The interviewers play with some basic problems and make them, more, complicated. But, let's say I want to change this, problem. Let's say the movements are the definition of movements. Let's say we have, this is a chessboard, right? And the movements, well, let's say it is not, the movements are, the knight movements, right? I don't know, maybe my spelling is not correct. What does it mean? The knight in the chess, let's say if we have, this grid, so let's say I'm here. The candidates are, if we have knight, we will have this, 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 this. This is, some L, movements, right? If we are in the blue dots, we have 8 possible neighbors. Okay, so let's say we change the problem, simply, only we change one of the assumptions. So what is the shortest path from the source to destination? Exactly same problem, but the movements in your piece is a knight in the chess, and you want to find the shortest path links. As you can see, these are the movements, right? The same, that's the same. We have 0 and 1, and 0 is you cannot enter. So how we can change this? Only we need to update the potential neighbors. You don't need to change anything. Only you need to change the potential neighbors. What is the potential neighbors? We have 8 potential neighbors, and that's it. So how we can do that? So if we have let's say SR and SC here, let me write I and J to make it easier. Shorter actually. I and J. So if we have I and J, what is this? The top, it is I minus 2, J plus 1. And this guy is I minus 1, J plus 2. And you can simply, write all of these guys, and you will have, instead of, 4 pairs here, you will have 8 pairs. The only place you need to change is here. And actually, let me change these guys, to I and J to make it, easier. I and J. I and J. And let's say, because I want to write the code a little faster, I, J. And here, I want to update these guys. Let's say we have this really, this change. But, I saw lots of people, when we change, the definitions, they, got confused. But if you be really fluent in the basic, problem, it is nothing. It is, let's say here we have I and J. The neighbors will be I minus 2, J plus 1. Will be I minus 1, J plus 2. And the next one will be I plus 1, J plus 2. And you actually add all of these guys here, and you don't need to change anything. And you will find, the shortest path. And if they say, we have bishop, we have any piece of, just any, really complicated movements, right? Let's say we have a scenario for movements, right? I mean, we have a problem like a snail in the cracking the coding interview textbook. The snail, goes back, and when hits, 0, go back, 1. We can define lots of, scenarios for movements, but nothing will be changed. Only your neighbors will be changed. and you have to implement that scenario. How, what's happening, you need to find only the updating the potential neighbors will be changed. That's it. Any question for this part? We can have any kind of movements. Let's say we have queen in the chess. Queen can go right and left and also diagonal, right? So again, for any node you will have 9 potential neighbors. You should add in all of them in the potential neighbors, right? If you have rook, you will have this or this, and actually we solved in the first one. And knight, you saw how we updated this. Or any customized movements, you can update this. So that's why you can solve any problem in the grid, or sometimes they say maze, doesn't matter. This is what's the term. You will detect that. You can use the BFS, and also with DFS we can solve, and it can be optimal if we use the DFS and apply the memoization. Actually, we did the memoization and dynamic programming in some sessions of the previous meetups. I will go through them again because dynamic programming is really important.